Hello, welcome to this lesson of our study of partial differentiation. Okay, so in this lesson we'll just go through how to find the equation of a tangent plane to a surface. Okay, remember we've already done previous videos on tangent vector. Okay, so if you remember, it was something about a plane that is of traces to something. If you remember, that was in a vector form that we say rho of xy or rho of t was equal to some f of ab comma something like that. Okay, it was actually something like this: a comma b comma f of ab, okay, then plus t into if that was, let's say, for traces to y or something, then we'll have real x and the rest. Okay, if you remember, that is it. But now here you just want to find the equation of the tangent plane to the surface. Okay, so this is actually, let's start with the first one. Okay, so with the first one, this is how it looks like. Okay, find the plane tangent to the surface. Z equals x cos y minus y e to the x at the point P, which is 0, 0. Okay, so here we say z is equal to that, so it means that we can actually represent z, which is a function of both x and y, by just f of xy. Okay, so you can say z is equal to f of xy, and this is equal to x cos of y minus y e to the x. Okay, and the formula we'll use here is z minus z naught. Okay, or you can say let's replace it by z. Okay, z minus z naught is equal to fx simplified at a point P. Okay, then x minus x naught, and plus fy simplified at a point P, then y minus y naught. So this is very simple. In other words, it's like writing the Taylor series of a function in two variables. Okay, if you study clearly, it's like writing a Taylor series of a function in two variables and truncating it at the first derivatives. Okay, all right, so just keep this in mind. So to start with, we said our f of xy is equal to x cos of y minus y e to the x. Okay, and you know that the point is what? 0, 0, 0. So this means that this 0 is what? X naught, this is y naught, and this is z naught. Okay, so when you are quoting our formula, wherever you see those y naught, x naught, z naught, you put these values there. Okay, now fx is simply differentiating with respect to s, and that will give us cos y minus y e to the x. Okay, now you have to simplify at p. Okay, so fx at p, putting these values in wherever you see this is x, this is y, okay, and this is z. So wherever you see those values in fx, you put them in, or those variables there. Okay, so when you put x equals 0 in here and y equals 0 in all of these, okay, we'll get fx at p to be 1. Okay, then fy is also equal to minus x sine y minus e to the x, and then this two fy at p will also give us -1. Okay, just put 0, 0 in place of x and y, and you see now we are good to go, because we know that z naught is equal to 0 from this. Okay, so simply our tangent plane to this surface, okay, this is the surface we are talking about, this surface is then given by the tangent plane. Let me write it a different color. Z minus z naught, which is 0, equals fx simplified at p is 1 into x minus s naught, which is 0, okay, plus fy simplified at p, and that is -1, so it becomes -1 into y minus 0. So in other words, or in simple terms, we have z equals x minus y. So this is the tangent plane to the surface. So in other words, it's like a linearized form, okay, of this. We'll talk about linearization very soon, don't worry. Okay, so this is the second question. Find the equation of the tangent plane to the surface. Okay, so here the surface is given in an equation form. Okay, so I believe you know what we will use here. We'll use implicit differentiation. Okay, so now using the implicit differentiation, you have to send everything to the right side or the left side of the equation. So s squared z minus y cubed z to the 5th power plus xy minus 9 equals 0. And we said you let f of x, y, z be equal to s squared z minus y cubed z to the 5th power plus xy minus 9. Okay, so now with this, what we do here is we said that what you use here is let me code the formula. The formula is z minus z naught equals fx, simplified as p x minus x naught plus fy simplified as p y minus y naught. Okay, but here if you consider clearly, it's an equation form. So what you will use here is, instead of fx, indeed we will use a z minus z naught here. Then instead of fx, we will use del z del x simplified as p, okay, since this is implicit, plus del z del y simplified as p y minus y naught. I hope this is okay for you. So that is what we'll use. We won't use the first one since this is implicit. Okay, so you have to know the reason why. Now with this, we know that from implicit, let me write the function. After writing everything or putting everything on the left side, we said f of x, y, z will be equal to s squared. Okay, if you remember, we've done implicit differentiation in partial derivative. So s squared z minus y cubed z to the 5th power, okay, plus xy minus 9. Now you said del z del x is equal to minus fx over fz, okay, and del z del y is equal to minus fy over fz. I hope you can see this. So now fx is equal to what? We have 2x z plus y. I hope this is okay for you. And you have fy being equal to minus 3y squared z to the 5th power plus x. Okay, and then fz is also equal to s squared minus 5 y to the 3rd power z to the 4th power. Okay, so we have them. Now let's put them back in these ones. Okay, minus fx and minus that. Okay, so we know that del z del x is equal to minus fx over fz, and that is equal to minus fx give us what? Fx is 2x z plus y. Okay, so 2x z plus y all over fz, which is s squared minus 5y cubed, okay, z to the 4th power. Now this, let's simplify it at the point p. So del z del x at p. So what is p? P is given in the question as what? 1, 2, negative 1. Okay, so 1, 2, negative 1. So wherever you see x, you put this. Wherever you see y, you put this. Wherever you see z, you put negative 1. Okay, so these are the corresponding coordinates. So you put them inside and simplify. Del z del x will give us 0. You can try and see. Okay, it will give us 0. Now del z del y is also equal to minus fy over fz, and this is equal to negative of negative 3y squared z to the 5th power plus x, okay, over s squared minus 5y cubed z to the 4th power, okay. Now at p del z del y, simplified at p is also equal to 1 over 3, okay. So that one too, you put your x and y and then z values in, and you get that. So very simple. You know that the point is 1 comma 2 comma negative 1, okay. So you know z minus z naught, and this z naught, okay, negative 1. So let me code the formula: z minus z naught into del z del x into x minus x naught plus del z simplified at p, please, del y simplified at p y minus y naught, okay. So now z naught is this, okay. This is x naught, okay, this is y naught, and this is z naught. All right, so we have z plus 1, okay. I hope you can see, equals now del z del x simplified at p was 0, so everything here will tend to 0. The whole of this place will be 0, okay. So we have 0 plus this one to give us 1 over 3, then y minus y naught, which is 2, okay. So in simplifying, we have z being equal to 1 over 3y minus 2 over 3 minus 1, okay. So that will give us minus 5 over 3. Either you do it this way, or you say 3z is equal to y minus 5, or so you can write it in different ways, or you can bring everything to the right side and say 3z minus y plus 5 is equal to 0. Or somebody can also make sure that the y is positive, so y minus 3z minus 5 all can be equal to 5, okay. Is it okay? Plus, is it minus 5? Okay, so minus 5 is equal to 0, or any way. So you can, I'm just trying to show you ways your question or your answers can be given, okay. But the most preferred one is either this or this one, okay. I hope you can get it. So thank you, and don't forget to subscribe to my channel. In our next discussion, we'll talk about linearization and linear approximations, okay. See you next time.